Today we're going to talk about what acceleration is. So far we've talked about position and changing position. We call that displacement, how far you are from where you started. And the rate at which we move or change that displacement, we call that velocity. So velocity, though, is not always constant. So we need a way to describe when you step on the gas pedal, your car speeds up, your velocity increases, and we need a way to talk about when you step on the brake, your velocity decreases and your car slows down. So we need a term and a calculation in order to describe changing your velocity. So acceleration is the rate of change of velocity. So how fast you're speeding up or how fast you are slowing down. So our definition there, acceleration is the rate of change of velocity. And acceleration has units of meters per second squared. So meters per second squared is the unit for acceleration. So when an object changes its velocity or changes its speed, it is accelerating. Whether that's accelerating in the positive, so speeding up, or accelerating in the negative and slowing down. So acceleration in the same direction as velocity, the speed is going to increase and you're going to have a positive acceleration. So if you're speeding up, you have a positive acceleration. If we're going in the opposite direction, so our acceleration is, or we're slowing down, our speed is decreasing, we're going to have a negative acceleration. So here, velocity and acceleration are in opposite directions. So how do we calculate acceleration? So acceleration can be calculated using this equation. So our acceleration, symbolized with the letter A, equals our final velocity, so how much we're moving at the end, how fast, minus the initial velocity, so VI initial, all divided by time. So if we remember, acceleration has units of meters per second squared. Velocity, so both of them have units of meters per second. And time has units of seconds. So both velocities are meters per second, time is measured in seconds, and acceleration is meters per second squared. And if you notice, velocity, final, and initial are in parentheses. So you have to do the subtraction first in your calculator. So subtract them, and then you're going to divide by time. Let's try a couple examples. So a roller coaster car is rapidly picking up speed as it rolls down a slope. It starts down the slope, its speed is 4 meters per second. But 3 seconds later, at the bottom of the slope, its speed is 22 meters per second. What is the average acceleration? Okay, so our equation, acceleration equals final velocity minus initial velocity, all divided by time. Okay, so it wants to know what is the average acceleration. So we're solving for A. Now my final speed at the bottom is 22 meters per second. That should be in parentheses. Minus my initial, how fast I'm going at the top, so 4. All divided by the time it takes me to do that. So it says it takes 3 seconds. So I'm going to divide by 3. So let's simplify the top. 22 minus 4, it's in parentheses, we have to do that part first. So that would be 18 divided by 3. So our answer should be 6 meters per second squared. Okay, let's try number 2. Problem number 2. So suppose a jet airliner starts at rest at the end of a runway and reaches a speed of 80 meters per second in 20 seconds. What is its acceleration? So again, we're solving for acceleration. So I'm going to take my final speed. So at the end of the runway, I'm moving 80 meters per second. At the beginning of the runway, it says I start from rest. So starting from rest means my initial speed is 0. So sometimes it won't be a number. Sometimes you got to look for those words like rest. And then we're going to divide it by the time, so it takes 20 seconds to do that. So 80 minus 0 stays 80 on top, divided by 20 to get my answer. So my acceleration is going to equal 4 meters per second squared. So we got to look for those words sometimes to know if our initial velocity should be 0. So if it says it starts from rest, that means VI, our initial velocity, is going to be 0. So let's try one more together here. So now imagine a skateboarder is moving in a straight line at a constant speed of 3 meters per second and comes to a stop in 2 seconds. What is the acceleration? So still finding acceleration. So my final velocity. So at the end, what am I moving? And it says I come to a stop. So that means my final velocity is 0 because I come to a stop. Minus my initial speed. So initially I was moving 3. Divided by my time of 2. So here was 2 seconds. So my acceleration is going to be negative 3 divided by 2. So negative 3 divided by 2 gives me an answer of 1.5 meters per second squared. So it's negative this time because I'm slowing down. I come to a stop. Okay. So we got to always make sure we look for keywords like start, stop, okay, because those will give us some numbers to plug in. And then we got to always make sure we do the subtraction on top first, and then we're going to divide by time. So we never want to divide first and subtract. So always do the what's in parentheses first, and then we're going to divide by time. So the last thing we're going to want to talk about is our graph of this. So how do we graph acceleration? So acceleration will be graphed on a velocity time graph. So the slope of our velocity time graph is going to be acceleration. So how steep the line is on a speed time graph or a velocity time graph is going to give you the acceleration. So if we have a line that's increasing up like this, that means we have a positive acceleration and we're speeding up. So our speed is increasing. If we have a flat line that's not on the x-axis, so it's up here, that means our speed is staying the same, right? So here's speed on the y-axis. As we go across, it stays the same. So no acceleration, speed is constant. And then if we have a line like this that goes down to the x-axis, that means we have a negative acceleration and our speed is decreasing. So we're slowing down. And then finally, if we have a point or a line on the bottom x-axis, that means we're not accelerating and our speed is 0. So 0 would be here on the scale. So anywhere on this line, x-axis is a speed of 0. So there are two types of accelerations when they are 0. So when you're not moving at all, when your speed is 0, so for example, here, or when you're moving at a constant velocity and your speed is staying at 8. So acceleration is 0 in both of these sections. Here, our speed is 0. Here, our speed is not changing. Okay, so let's try looking and analyzing a couple of these velocity time graphs. So here we have a velocity time graph. So let's describe what is going on. So from segment O to A, we are speeding up. So we go from a speed of 0 to 2 to 4 to 6 to 8 to 9 and finally to 10. So we have a constant acceleration because the line is straight, and we have a speed that is increasing, going up. From segment A to B, we are not accelerating. So our acceleration is 0 because the slope is 0. And our speed is staying the same. So we're staying at 10. So from here to 10, here we're at 10, here we're at 10. So our speed stays 10 meters per second. Okay, then we have a line that's going down here. So from B to C, our velocity, our speed is decreasing. So we go from 10 to 8 to 7 to 6 to 5 to 4 to 2 to 1 and finally to 0. So we have a negative acceleration. So here's our acceleration, it's going down. So our speed is decreasing and we're slowing down. Finally, from C to D, our velocity, if we look, is 0. So we're not moving at all. So our acceleration is 0, our velocity is 0. So remember, our acceleration up here was also 0, but our speed was constant. It's not changing. We're not changing or accelerating. Here, our acceleration is also 0, but it's because of our speed being 0. So if we're not moving, obviously we don't have an acceleration. Finally, from D to E, we're speeding up. So we go from 1 to 2 to 4 to 4 and then up to 5 meters per second. So our speed is increasing. We have a positive acceleration. And then finally from E to F, our acceleration goes to 0 because the slope is 0. And our speed is staying the same. So our speed stays 5 meters per second. So positive acceleration, speed increasing. 0 acceleration, speed is staying the same. Negative acceleration, velocity is decreasing, or speed is decreasing. Here our speed and acceleration are both 0, we're not moving. Here we're speeding up, acceleration is positive, constant. And then here our acceleration is 0, not changing. Our speed is staying the same. So let's answer some questions about this. So here we have another graph. So it's a velocity time graph. So our velocities, our speeds are on the side, our time is across the bottom. So what is the acceleration of the car between 0 and 3 seconds? Okay, so if we remember our equation for acceleration is final minus initial. So our final speed looks to be 15 minus our initial speed for this segment between 1 and 3 seconds. So our initial is 0. And it's taken us 3 seconds. So we're looking at the first 3 seconds. So 15 minus 0 is 15. Divided by 3 would give us an acceleration of 5 meters per second squared. So we're looking at this first line here. Okay. Question 2. Between 3 to 5 seconds, so from here to here, the car is still accelerating, true or false? So remember, accelerating means your speed is changing. So does our speed change from here to here? And the answer would be false. Our speed is not accelerating, and we're not speeding up, we're not slowing down. Our speed stays 15. So there is no acceleration. So flat line means no acceleration. And then lastly, we have this last section here. So question 3, how would you describe the movement of the car between 5 to 10 seconds? So that last line, how would our car be moving? So from here to here, our speed is what? It's going from 15 all the way down to 0. So we would say our velocity or our speed is decreasing, and our acceleration would be negative or going down. And so a lot of these laws that we have been learning about, so velocity, acceleration, are all things engineers have to take into consideration when they're designing buildings and structures, and specifically rides. So amusement park rides. So they can reach high speeds, high accelerations on a lot of the steel roller coasters, and they have to design them so that the speeds and accelerations don't reach the maximum and cause failure. So they have to take into consideration all of these values to design safe and reliable rides.